Hi dears, welcome to my channel. Today we are discussing part B of magnetic effect of electric current, which is the lesson from class 10. In part A, we have seen how the current carrying conductor is behaving like a magnet when it is in the electric field. In part B, we are discussing some important concepts. Force of the current carrying conductor in the magnetic field, Fleming's left hand rule, then electric circuits for domestic purpose, difference between AC and DC, why parallel connection is given for the domestic appliances, two types of circuits, faults and the safety measures. In faults, we will see overloading and short circuiting, and in the safety measures, we will see how a fuse will work and what is earthing. Okay, shall we quickly go into the class? Up to this extent, we have seen a current carrying conductor. When it is kept in the electric field, they will be experiencing a magnetic field and they will be themselves acts as a magnet. Here, when we are placing a magnet from outside towards that conductor, we can see that a force is experiencing by the conductor on that external magnet. It experiences electric field as well as magnetic field. They are mutually perpendicular to each other, and this will experience a force, and that force is perpendicular to both electric and magnetic field. It can be easily seen with the help of Fleming's left hand rule. What is the rule saying? If we are stretching the fingers of left hand in such a way that the forefinger is showing the direction of the magnetic field and the middle finger is showing the direction of the electric current, then the thumb will show the direction of the force which the conductor is experiencing. Okay, so how can we easily find it out? In a nuclear family, father, mother and child will be present, isn't it? If we are representing the forefinger as mother, okay, and if we are representing the middle finger as children, then the thumb will be in the direction of force, that is father. Okay, so if we are keeping the forefinger and the middle finger in this direction, the thumb will be in this direction. So mother, child and father. Okay, that is magnetic field, current and force. Okay, in this manner it will be very easy for you to understand in which direction the force will be experiencing. So based on that, many problems will be asked for you. If they are giving in this manner, see, if they are showing that the magnetic field is in this, is showing in as this dot and C is the current, then what will be the direction of force? If they are asking, we can easily find out with the help of Fleming's left hand rule. This arrow, this circle shows that magnetic field is showing towards you. Okay, so in this direction it will be. And what is C? C is the current. In this direction it will be. So what will be the magnetic field? What will be the force? The force will be directing downward. So in which direction the force will be? Force will be experiencing downwards. Okay. Secondly, if they are giving in this manner, this shows the direction of magnetic field, and again this shows the direction of current. What will be the direction of force? If it is a question, we can find out. If crossing sign is given, it shows that magnetic field is experiencing backward. Here the magnetic field will be. Here it will be backward. Then what will be the direction of the current? Current will be in this direction. So this will be the thing, isn't it? You should not change the left hand for the right hand. It will be always with the left hand. Then only the things will be clear. The answer will be correct. Okay. If the magnetic field is in the backward direction and if the current is in this direction, what will be the force? The force will be showing upward. So upward will be the direction of force. Okay. And instead of current, if they are saying that if the magnetic field is in this direction and if the electrons are moving in this direction, what will be that? The movement of electron is exactly opposite to the movement of electric current. Okay, if the direction of magnetic field is front and if electrons are moving in this direction, which means what? The current is moving in the opposite direction. So the current is moving in this direction. Field is in one direction and the electric current is in opposite direction of that of the flow of electrons. Then what will be? What will be the direction of force? The force will be acting in the upward direction. Like that they will ask. And if they are saying the alpha particles are moving in a particular direction, alpha particles movement is equivalent to the direction of electric current, then also we can find out how will be the direction of force which the conductor is experiencing. Okay, by this way also the questions may be arising, and Fleming's left hand rule give you an idea how the direction of the force will be. What are the applications for this? There are various applications. In the applicant level, we can say the electric motor, generator, microphone, loudspeaker all works on the principle of the magnetic field with which the electric current is experiencing. All works under the principle of the interaction between the electric current as well as the magnetic field. So, this is the very important part. Now, a question. Is a magnetic field created in a human body? Yes, magnetic field is created in a human body. Actually, the human body is having a small amount of ionic charges present in them. Because of the movement of these ionic charges, electric power or electric current is generated in our human body. Because of the presence of the electric current, magnetic field also will be generated. Have you heard of MRI scan? This MRI scan utilizes this magnetic field for diagnosing the disease. MRI scan actually utilizes this magnetic field for creating some images. By analyzing these images, they will be able to see whether there is a problem in the body or not. Now we are going to see the domestic electric circuit. Actually, we know the electric circuits are of two types, alternating current and direct current. Which current is getting inside our home? Electric current which is generated for the domestic purpose is alternating current. Why? Direct current is the one in which the direction of the current remains the same, while the alternating current will be having fluctuating direction. That means direction will be reversed over time. In India, the frequency of the AC current is 50 Hz. Because of this alternation of the direction of the current, the electric current can travel to a long distance with very less loss of electricity in the case of AC. That's why AC is preferred for the domestic purposes. As the electricity is entering into our home, first it will enter into the electric meter and then it enters into our mains. Then only it will be entering to various appliances which are connected in our home. In which direction the electricity is moving? Is it in parallel connection or in series connection? For the homes, the connections are in parallel because maximum voltage has to be reached to every appliance. For making that surety, the parallel connection is given. Moreover, if one appliance fails to function, it will not affect the other appliance at the home. If the connection is given in parallel connection is preferred. Okay. Then, what is the potential difference which is maintained? Potential difference, that is voltage which is entering in our home, is 220 watt. That is potential difference which is maintained is 220 volt. Thus electricity with 220 volt and with 50 Hz are entering inside our home. Okay, enters in the home. We can see, if we are checking a wire, we can see that two wires are coiled each other. One is in red insulation and the other is in black insulation. Have you seen? The red insulated wire is called the live wire and the black insulated wire is called the neutral wire. What is this live wire saying? The live wire is the one which carry current from the power source to every appliance. Okay, so it carry 220 volt and having the frequency of 50 Hz. Okay, and it is giving electricity to each appliance. And what is the neutral wire doing? The neutral wire is getting back the excess electricity from the appliance back to the power source. So these two wires are very important for the connection. Okay, then only the circuit will be completed and this results in the working of the appliance with electricity. Okay, and inside the home we can see two types of circuits, that is lighting circuit and power circuits. That is lighting circuit, from the name itself we can see. Lighting circuits is the circuits which are having less current for it to work. For example, bulbs, fan, then charger has to be charged, that charger. All these needs very less electricity to work. So the current which they are drawing is only 5 ampere. Okay, so they are called lighting circuits. Then the second is power circuit. Power circuits are the one which needs more electric current to say 15 ampere. For example, geyser, then AC, then to say washing machine, fridge. These appliances draws much more current. So 15 ampere connection is there. That is called the power circuit. Okay. Then again, if you are seeing, you will understand that There are two types of pins, 2 pins and 3 pin. Have you seen the 3 pin plug? That is, one will be the central most, the topmost one, which is much more wider, and the other 2 pins are the ordinary one. So the 3 pin set means what? Along with the live wire and neutral wire, there is a third wire for them, that is earth wire. Why earth wire is giving? Earth wire helps to makes the appliance safe from electric shocks. How the earth wire is functioning, we will see when we are discussing about the faults of the electric circuits. Now we are going to see the faults and safety measures in domestic electrical circuits. Have you heard of the word overloading? What is this overloading? If the high voltage is passed through the electric circuits, or if various electrical appliances are connected to a single socket, and if all the appliances are switched on simultaneously, what happens? Each electrical appliance will draw electric current, isn't it? If much more electric current is passed through the wire, and if the wire is not able to bear this electric current, what happens? It gets heated up and it will result in firing. This is overloading. Okay. Then there is yet another thing, that is short circuiting. Have you heard of the word short circuiting? Consider a case. If the insulation is not proper to the live wire and the neutral wire, because of this, the live wire may come in contact with the neutral wire. Then what happens? The live wire and the neutral wire, if come in contact with each other, the resistance will be 0 and the current will be infinity. Means much more current will be flowing through these wires. So the wire get heated up and start to firing. Appliances also will start to get firing because of this short circuiting. These are the fault in the domestic electric circuits. Then we are going to see about the safety measures for that. The first one is fuse, which is the one you have already learned, isn't it? For avoiding this overloading, the live wire is in contact with the fuse wire. What is the fuse wire specialty? Fuse wire is the wire which is made of tin and lead in the proportion of 1:3 ratio. So they will be having very less melting point, that is about 200 degrees Celsius only. Okay. So if the electric current is flowing and makes the wire to heat it up about 200 degrees Celsius, what happens? The fuse wire breaks. So what happens? The circuits breaks. So what? The current will not be able to move towards the electrical appliance. So the overloading can be overcome by this way. So fuse wire is an important safety measure to avoid the overloading of the electric current. Okay. Then the another one is earthing. What is this earthing? Imagine a case if the live wire is in touch with the metal body of the appliance. Consider a washing machine. If the metal body is in contact with the live wire, what happens? This metal body fully gets electric current, and if we are coming in touch with this metal body, we will get shock, isn't it? So the metal body should be saved from this shock. How can it be done? By earthing the appliance. Electrical appliances which are drawing 15 ampere current is having 3 pins. I have already told you. There is a big pin, that is the earth pin. Earth wire is the wire which connects the metal body of the appliance with the earth. If the metal body is in direct contact with the earth with the help of this wire, even though the electricity is passed to this metal body, that excess electricity will be moving directly to the earth. And even if we are touching that metal body, we will not get shock. Okay. So earthing is very important. If the electrical appliances are properly earthed and if the fuse wire is properly connected, we will be able to escape from almost all electric shocks, and the appliance will not be get damaged due to overloading or short circuiting. Okay. I am winding the class and we will meet in part C, where there we will discuss the index questions as well as some important board exam questions. Okay.